My question? Let's go. A 0.3 acid has a Ka of 1.8 times 10 to the negative 4. What is the approximate pH of the solution? So since we know it is an acid, we know it's going to donate its proton in solution. So let's draw out this formula. HCOH plus water, it's a weak acid, these are equilibrium arrows. It's going to donate a proton to water. Formic acid will now become formate, and water will now become hydronium. So now, at this stage, we have to set up our ice table. So we start off, initial change equilibrium. We start off with initial of 0.2. Water is not calculated in ice tables because it is a pure liquid and its concentration stays constant. Formate is 0. Initially, we assume 0 and 0, no change. And now the change comes with some value of x, and since formic acid is becoming formate, that means we're losing some amount of x. And since we're forming formate, that means we gain some amount of x. In total, 0.2 minus x, x. So now Ka is equal to products over reactants. Remember, we ignore water. So now let's solve. HCOH is just going to be x, and then 0.2 minus. Here, you can do this quick really trick. It's called, you assume x is really, really small. Sorry, you assume x here is really small. So basically, basically 0, because it's going to be very small. And this basically gets rid of this x down here. And now what we have is x squared over 0.2. And this problem becomes a lot more manageable, and it gives you a very good approximate solution. So now 0.2 times 1.8 times 10 to the negative 4, that is approximately 0.36 times 10 to the negative 4 equals x squared. And another trick here, since we're not on calculators, is when you do the square root of this, instead of 0.36, we can deal with it as 36. So 36 times 10 to the negative 6 now, since we move the decimal place to the left 2 times, we increase the exponent 2 times. And now it's much easier to square root this. So now we get x is, the square root of 36 is 6, and the square root of 10 to the negative 6 is always the exponent divided by 2, so negative 3. We're not done, we have to find the approximate pH. Now, the pH is equal to the negative log of hydronium. And since hydronium is equal to x, we can let x equal hydronium. Now, there's another neat trick to do this by hand. You don't need a calculator for this. Is first, whatever the exponent is, you bring it down here, absolute value of that exponent, and then you do the log of 6. This is a quick shortcut. You do need to know approximately what log of 6 equals to. It's a quick chart, and you should memorize this for the MCAT. And the log of 6 is approximately 0.8. So we get a pH of 2.2, and the closest value to that in our answers is 2, so answer is A.